Okay guys, hopefully things are still going well for you guys. Had to literally reset my whole iPad, lost a lot of the stuff I had on there memory wise and so on, but hey, that's life. Sometimes you just have to start over. But anyways, if I was going to review Unit 3 for IM3, here are some things I would think about. First of all, you got to be able to add, subtract with polynomials, bottom line. And I purposely picked one that had a minus in it because this is a more common mistake. You got to remember to distribute this minus. Okay, so here's what we really have. We have 9t plus 7t squared minus 6. The minus here again makes that minus 11t cubed. And then a minus 2t squared. Got to be careful with that sign. Got to distribute that minus. And the minus with this minus makes plus 14. So if you notice, this does not have any like terms. So I'm going to put that in front. Negative 11t cubed, because we always put them in standard form when we can. Highest to lowest power in order. Now I do have a 7t squared and a minus 2t squared. So that would be a 5t squared, right? I do have a 9t here and no other t, so I do have still a positive 9t. And then finally I have a minus 6 plus 14 is going to be a plus 8. And again, adding and subtracting, you're just combining like terms. With subtracting, like I just remind you of, you got to distribute that minus correctly. You miss a sign somewhere, obviously you're more likely to get a wrong answer then. So watch those signs. What else would be in Unit 3? Well, you're going to multiply and add and subtract with complex numbers. So I'm going to go with the area model since that was the most popular for a lot of you guys this year. And so that's what I'm setting up here. I'm going to take 4 minus 9i. Oops, not t, I. And I'm going to take 7 minus 5i across the top. So 7 times 4 is 28. Minus 5i times 4 is minus 20i. 7 times negative 9i is negative 63i. I'm basically doing distributive property, right? And then finally, negative 5i times negative 9i is 45i squared. But remember, guys, I squared always equals negative 1. So that right there becomes negative 1, which makes the whole thing a negative 45 there. Because 45 times negative 1 is negative 45. So what do I have? I have 28 and a minus 45. That I'm pretty sure is negative 17. I have a negative 20i and a negative 63i. That makes a negative 83i. So hopefully I haven't made any silly mistakes, even though I'm doing this at like midnight. Only free time I get nowadays, guys. Seems like late at night. But anyways, hopefully I'm doing them correctly and you're getting the gist. I squared is negative 1. You got to do distributive property. With minus, you better distribute the minus. Now what else would be? Oh, let's do another one. Because sometimes they add an extra I in there. So check this out. I'm going to do 4i times 3i first. And I'm going to get 12i squared, which is a negative 12. Remember, I squared is negative 1. Now I'm going to times it with the binomial here. So negative 12 times 7 would be negative 84. And negative 12 times 5 would be negative 60i. So, add, subtract polynomials. Multiply with polynomials, as well as with complex numbers. That's all part of Unit 3. Now, let's see what else would be on there. Oh, factoring. Now, guys, look at this problem right here. I hope that you guys recognize I have two perfect squares. 25x squared is really a 5x squared. I have a minus. And then the 1 is an awesome number because it's 1 to any power, right? But it's a 1 squared in this case. So I have a difference of 2 squareds, which means I'm just going to do 5x times 5x, and 1 times 1, make 1 a plus and 1 a minus to get the negative. And that's how you factor a difference of 2 squares. Now what else would be on there are at least 1 or 2 cubes that you have to factor. So take a look at this one. This one has a bunch of negatives to try to trick you, but do you guys understand that negative 8 is really a negative 2 that's cubed? Okay, this one's going to have a little tricky because of the darn negatives. And 64 is really a 4x that's cubed. And we do have that minus between them. So we're doing the difference of 2 cubes. Now, to save time, guys, you need to reference the other video or two I made on this already. I did it earlier this week or late last week. But anyways, here is what I'm going to do. This is my A, basically. This is my B. And I know the difference of 2 cubes. Now watch, be careful with the signs. I'm going to take my A, which happens to be negative 2. And I'm going to minus my B. In other words, I'm going to do A minus B. Oh, sorry. B, of course, is 4x. Told you I'm tired. It's late at night, guys, but I'm doing this for you, hoping to help you. So we just did A minus B. Now we're going to times that with A squared. So negative 2 times negative 2 is positive 4. Because we're doing a minus or difference of 2 cubes, this has to be a plus here. And now I'm going to times together. Now watch carefully. A times B. A is a negative 2. B is a 4x. So that's a negative 8x. And finally, I'm going to add B squared. 4x times 4x is 16x squared. Now notice, I do have a negative to deal with here. So long story short, the correct answer is negative 2 minus 4x times 4 minus 8x plus 16x squared. I think we ought to do one more cube just to make sure we got it. So guys, here we have 2 perfect cubes again. Y cubed is literally y that's cubed. I have a minus. The 27 is a 3 cubes. Got to know those cube and square numbers really well, guys. Got to recognize it. But anyways, here's how we would factor this one. I would take the A minus the B, as we said. A is the Y, B is 3. I would times that by the A squared plus, I would times together the 3 and the Y. And then I would do a plus, and I would do B squared. So 3 squared is 9. Done. That again is how you factor the difference of 2 cubes. Now watch carefully. Let's say that this was a plus instead. Here's the difference. This would be a plus. This here would have been a minus. That's the only thing difference between sum and difference of cubes. Hopefully you caught on to that. Let me undo all that messy work though. There we go. There's our original problem I came up with. Now what else would be on the Unit 3 that we got to review real quick is solving quadratics. Take a look at this one, guys. Now before we solve this, you have to understand we have to get it equal to 0. Standard form equals 0. So the first step has got to be adding 14 to both sides. So notice I have m squared plus 9m plus 14 equal to 0. I want it standard form here equal to 0 there. Now that it's set up, guys, listen carefully. I could do the quadratic formula right now, but try to do factoring first. If I do an x, for example, I want a 14 and a 9, right? 2 times 7 is 14. 2 plus 7 is 9. So I have an m plus 2 times an m plus 7 equal to 0. And look, I've already found the answers, right? They're easy to do. Right here, I know negative 2 is one of my solutions. I know right here, negative 7 is my second solution. Again, you could have done quadratic formula on this one, but if you're good at factoring like I am, guys, do the factoring, please. If you did do the quadratic formula, you should come up with the same answers. Maybe you ought to practice that, by the way. Okay, let's do one more and then we'll call it quits. This one, again, is another quadratic. There happens to be a 2 in front, but I'm going to factor this one and once we have it set up. First thing I must do is minus 3x both sides. So I have 2x squared minus 3x minus 20 equal to 0. Now I'm going to factor this one with the x method. Most likely the teacher that you have right now likes to use the x method, and their method is going to be hopefully similar to mine. I'm going to take the 2 times the negative 20, that's negative 40. That's got to be my product. I know the middle term is my sum is negative 3. So how are we going to make this work? Well, do you agree that 8 times 5 is 40? To get a negative 3, I need negative 8 plus 5, though. And, of course, a negative times a positive will give me the negative there. So I'm almost there. I know it's going to be x minus 8 with an x plus 5 equal to 0. The only thing I have to be aware of is this is a 2x squared, though. You remember that, guys? So the 2 has to be either there or there. So what do? The 8 divides by 2, right? So then we times this second factor by 2. That's the trick. So right here, I have x minus 4. 8 divided by 2 is 4, right? And right here, of course, I have 2x plus 5. It's equal to 0. If you times this, guys, you will get back to where you started from there. Okay? But now all we have to do is solve. This is easy. 4 minus 4 is 0. There's one of our solutions. This is a little bit more difficult. Let's show our math here. I know if 2x plus 5 has to equal 0. 2x has to equal negative 5. I minus 5 both sides. And then x is going to be negative 5 halves divided by 2. And most likely your teacher likes the fractional answer. So your answers are going to be 4 and negative 5 halves. Okay, that's going to be your two solutions. If you, however, divide that and make that negative 2.5, I'm sure your teacher will accept that as well. So keep that in mind. Most likely, though, especially if it's multiple choice, it's going to stay as an improper fraction, negative 5 halves. But guys, those are some of the key things you should know for a Unit 3 exam in IM3. What are they again? Solving quadratics. How? Make sure you set it up correctly. Standard form equal to 0. You could do the quadratic formula sometimes, but as I just showed you, factoring is usually quicker and more efficient. You better know your cubes. You better know your squares. You better know your complex numbers. You better know your distributed property. You better know how to add, subtract with complex numbers as well as with any polynomial. Good luck, guys. I'll see you around.